Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And as always, take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Gold Rectangularity by Nicholas Duhale, and here are the rules. Excuse me. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell regions. And along gold lines, digits do not repeat, and no two digits appearing anywhere on the line can be consecutive. So these are Nabner lines. So as an example, you could have something like, say, 2, 7, 9, 4 here. And this would be valid because there are no repeats on this line and no two digits on this line are consecutive. 2 is not consecutive with 4, 7, or 9. 4 is not consecutive with 2, 7, or 9. 7 is not consecutive with 2, 4, or 9. And 9 is not consecutive with 2, 4, or 7. What would not work, though, here is something like 2, 3, 7, 9, because 3 and 2 are consecutive. 1 also would not work, neither would 8, neither would 6. 5 could actually work, so that would work fine. But you could not have any two digits that are consecutive or repeated, so you can't have 2, 7, 7, 9 here as possibilities. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, to add up to 15, there's only two possibilities for two digits. It's either 6, 9, or 7, 8. And 7 and 8 are consecutive, so this must be a 6, 9 pair here. Same with 5. Adding up to 5, you can either be 1, 4 or 2, 3. But 2, 3 are consecutive with each other, so this must be 1, 4 as a pair. Okay, where do we go from here? 4 is guaranteed to be 1 and 3 as a pair, so that's fine. So that means... 16 is 7, 9 as a pair, and 6, 9 as a pair eliminates 9 here. So this must be 7, guaranteed. That adds up with 9 to add up to 16 here. Okay. So this 13 adds up to, these two digits add up to 13. That could be either 4, 9, 5, 8, or 6, 7. But neither of this cannot be 4, 9, because the 6, 9 pair and the 9 here eliminate 9 as a possibility for these cells. And this 6 here, 9 as a pair, and the 7 eliminates 6 and 7 as a possibility. Well, actually, 6 and 7 doesn't work because they're consecutive also. So this has to be 5, 8 as a pair here. Okay. That means this pair of digits adding up to 13 cannot be 5, 8, because of the 5, 8 pair here eliminates any possibility of 5 or 8 there. And if this can't be 5 or 8, this digit can't be 5 or 8 to add up to 13. And 6 and 7 doesn't work because they are consecutive. So this must be a 4, 9 pair here. Okay. That is interesting. These digits cannot be consecutive. These digits cannot be consecutive with 6 or 9. And they can't duplicate 6 or 9 because there are no repeats. So that eliminates all possibilities from 5 through 9, right? 9 is a duplicate of 9. 8 is consecutive with 9. 7 is consecutive with 6. 6 is a duplicate of 6. And 5 is consecutive with 6. So these two digits have to be from 1 through 4, then, guaranteed. And it's the same thing with this Nabner line here. 1 through 5 are eliminated because 1 is a duplicate of 1. 1's a repeat of 1. 2 is consecutive with 1. 3 is consecutive with 4. 4 is a duplicate of 4. 5 is consecutive with 4, so these must be 6 through 9 here. This can't be 7 because of 7 in the box. This can't be 8 because of the 5-8 pair in the column. What else do we have? 4 and 9. 9 can't be here. So we can't have 4 or 9 available because they are repeats. 8 is consecutive with 9. 3 and 5 are consecutive with 9. That just leaves... So we can't have 1 here. Because if we had 1 here, we are... First of all, we are guaranteed a 1 in this pair of digits with 1 and 4 adding up to 5. We are guaranteed a 1 here in columns 6 and 7 to add up to 4 with 3. So that means 1 can never appear in columns 6 and 7. So we can't have 1 here. You can't have 3, 5, or 8. So one of these is going to have to be a 6 or a 7 here. And the other one's going to have to be a 2. Because 6 and 7 are consecutive with each other. So obviously that doesn't work for both of them to be 6 and 7. And again, 3, 5, and 8 are eliminated because they are consecutive with 4 and 9. 4 and 9 are eliminated because that's a duplicate of 4 and 9. And 1 is eliminated because we already have 2 1s in this column. These digits cannot be 6 through 9, so they have to be 2 through 5 here as possibilities. No 4 here, because we have a guaranteed 4 in this cage adding up to 13 with 4, 9, and this cage adding up to 5 with 1, 4. So that means this is going to have a 5 and 1 out of 2 or 3 here. Because 2 and 3 are consecutive with each other, so we're guaranteed a 5 here. Which means we are guaranteed there are no more 5s in column 6 and 7. It's because 5 and 8 is guaranteed here, and 5 is guaranteed here. So this cannot contain a 5 there. We can't have 1 through 4 there because that's consecutive or a repeat of 1 or 3. So this must be 6 through 9 here. And this can't be 9 because of 9 in the box. This can't be 8 because of the 5-8 pair in the column. These two digits add up to 6. It's 1, 5 or 2, 4. And this can't be 1 or 4 because of the 1, 4 pair in the row. So this is 2, 5, which makes this 1, 4. Here, we cannot have 7 or 9 here because of 7 or 9 in the column. So what are the possibilities here for this Nabner line here? Well, if we try to have 1 and 5, that actually works if we have 3 and 8. Okay, so that's not helpful. To add up to 14, it's either 5, 9, or 6 and 8. Either of those work. But since one of these is 6 or 9 here, and this must be 6 or 9, that eliminates 6 and 9 in the rest of the column. To add up to 11, it could be 2 and 9, 3, 8, or 4, 7. 5, 6 does not work because they are consecutive with each other, but this can't be 9 here because of 9 in the 9 having to be one of these two digits or here in the column. That means this can't be 2. To add up to 8, or sorry, to add up to 9 here, it's 1 and 8, 2 and 7, or 3 and 6. Again, no 4 or 5, because those are consecutive with each other, so no 6 here because of the 6, 9 guaranteed in these 3 cells in that column. Okay. So we have a 5 guaranteed here and a 5 guaranteed here, which means there are no more 5s here. What digits are... So no 5, 8 here because of the no repeats. No 4, 6, 7, or 9 here is available. Those are 4 and 6 are consecutive with 5, 7 and 9 are consecutive with 8, which leaves just 1, 2, and 3 here available. And 2 is consecutive with both 1 and 3. So that can't be 2 here. It must be a 1, 3 pair. This 1, 3 pair in box 6 eliminates 1 and 3 in the rest of the box. So no 3 here, no 8 here to add up to 11. This 1, 3 pair eliminates 1, 3 in the rest of the column. I don't know how helpful that is, though. 10, it could be any combination of things. We just can't have 9 here because of the 6, 9 pair. So it could be 2, 8, 3, 7, or 4, 6. This can't be 7 because of 7 in the row. This can't be 6 because of the 6, 9 pair in the row. So that eliminates 3 here and 4 here. We are guaranteed of a 2 here. So if this is 1, 5, this has to be 3 and 8 here as the remaining digits. 1, 5 eliminates 2, 4 as a possibility here. And then also eliminates 6 as a possibility here because 5 is consecutive with 6. So this would have to be 3, 8 in that instance. Or if this is 2, 4, it would have to be 6, 8 here. Because 2 and 4 eliminate 1, 3, and 5 because they're consecutive, and 2 and 4 because they're the repeats. So that just leaves 6 and 8 here. So we're guaranteed an 8 here. We just don't know which it is. And either 3 or 6. To add up to 12, it could be any of those combinations. So 3, 9, 4, 8, 4, 5, 7. 4 can't be here because of the 1, 4 pair in the row. So therefore this can't be 8. Can this work if it's 5, 9? Yeah, it could. If it's 5, 9, we don't have 1 or 3 available because of the 1 through pair in the column. So it'd have to be 7 and 2 left. Right. No 1, 3 available. 5 and 9 eliminate 5 and 9 for repeats. No 4, 6, 8 for the remaining digits. So it would have to be 2 and 7 here if that were the case. If this is 6 and 8, that eliminates 5, 6, 5, 7, and 9 because those are consecutive with 6 and 6 and 8 because those are repeats. We don't have 1, 3 available, therefore this would be a 2, 4 pair here. So either way, we are guaranteed a 2 in one of these cells. This cannot be 2 because one of these cells must be 2. That leaves a 2 being here. So that 2 eliminates 2 in the rest of the box and row. So this cannot be 2. It's 5 and 1 adding up to 6, which means this must be 3 and 8 as a pair. 5 eliminates 5 in the rest of the row, so no 5 here, which means this can't be 9. 5 eliminates 5 here, so this can't be 7. We have a 1, 3, 4 triplet in box 5. That leaves the remaining digits as 5 through 9. That's not that helpful. Okay. 5's guaranteed here. 5's guaranteed here. Do, 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 do. Hmm. Um, hmm. We don't have ones or twos available anymore in rows 3 and 4. We have a guaranteed 2 here to satisfy this Nabner line. We have a 2 here, which satisfies this Nabner line. We have 1 here to make sure this is adding up to 5 with 1 and 4. And we have a 1 here. So, for 4 unique digits, without a 1 or 2 to add up to be not consecutive or not repeated with each other, it can only be 3, 5, 7, and 9. There's no other possibility without 1 or 2 available. So this cannot be 4 or 8. This has to be 3, 5, 7, or 9 available. No. This could be 7. We don't know. Okay. We don't have 9 available here. This could be technically 1, 2, 3, 4, 5, and 8. This could be everything almost except for 9. 5 is not available because we are guaranteed a 5 here and a 5 here. There's no 5s available. 4, 6, 7, 8 as a possibility there. So no 5 or 9 available here. So we have 1, 2, 3, 4, 7, 8, and 9. Again, this cannot be. How did I get the 9? 1, 2, 3, 4, 6, 7, 8. So this can't be 6 because either this is 6 or 9 and this is 6 or 9. So no 6 or 9 here. No 4 or 9 here. So 1, 2, 3, 5, 7, or 8 are possibilities there. What about this? I don't really know. This has to be 3, 5, 7, 9. So we're guaranteed a 5 on this Nabner line. Cannot be here. It must be here. Which eliminates 5 in the rest of the row. So this cannot be 5. Therefore, this is a 6, 8 pair. Which means 2, 6, 8 are on the line. So 7 is no longer possible. So this must be 4. So we have a 4 there, a 2 there. The 6, 8 as a pair eliminates 6, 8 in the rest of the column, so no 6 here, it's 9. No 9 here, it's 6. No 6 here, this can't be 3 to add up to 9. And these can't be 8 anymore because of the 6, 8 pair of the column. No 8 here, so this can't be 3. 6 eliminates 6 here. So it's either 2, 9 or it's 4, 7 here. That's interesting. 9 eliminates 9 in the rest of the box. This is 6 or 7 here. If we had 6 here, that would force this to be 7, which would be consecutive with each other. So this can't be 6. It's 8 or 9 there. This can't be 8, so this can no longer be 1 here to add up to 9. Okay. Remaining digits in column 4. No 6, 8, or 9. No 1 or 3 because of the 1, 3 pair in the row here. So that must be 2, 4, 5, 7 as possibilities. Okay. Remaining digits of column 8. We have 1, 2, 4, 5, 6. Right? No 1 here because of 1 in the box. No 4 here because of 4, 9 pair in the box, or the row. We don't have any information there, so that's fine. No information there. This can't be 1 because of 1, 3 pair in the row. Hmm. Okay. Um. Oh, I forgot. I think I forgot to describe the killer cages. Whoops. Uh. Well. Okay. Apologies for that. I forgot about that. I've already solved most of the waste done trying to solve this, so. Okay. Anyways. This digit cannot be 1, 2, or 7 here. If it's 1 here, that would force this to be a 2, 7 pair, but that would be consecutive with the 2 would be consecutive with the 1 here, so that's why this can't be 1. And if this were 2, 7, obviously if this were 2 here, it can't be 7, 2 as a pair here. That would be a repeat, and we can't have 1, 8 here because 1 would be consecutive with 2. And if we had 7 here, again, can't be 2, 7 as a repeat, but we have 1, 8 here, and 8's consecutive with 7. So this can't be 7 there. It's 3 or 5. That's interesting. We cannot have a 3 be on this line. If this were 3, that's consecutive with both 2 and 4, and the possibilities of this are 2, 9, or 4, 7. So this can't be 3 here. We only have 1 9 on this Nabner line because there are no repeats. So where is the other 9 in rows 3 and 4? Cannot be along here because of the way that the cages work, or the Nabner lines work. Cage here, Nabner line here, Nabner, and actually 9 in the column there. Means that can't be 9. We have a guaranteed double 8 here. So one of these is guaranteed to be 9. We don't know which. We don't have 8 available. We don't have 5 available. No 4, no 1 available. No 2 available. We already have 3 accounted for twice. So 1 is accounted for twice in those 2 rows. 2 is accounted for twice in those 2 rows. So it's 3, 1 here, and 1 in the Nabner line here. 4s are accounted for, 5s are accounted for, 6s are not necessarily. So we have a 9, this could be 6. But 6 can't be here because of 6 in the box. 7 is available, so this could be 7. And 8 is not available because we have an 8 guaranteed here and an 8 guaranteed here. Okay. Therefore, we have a 3, 7, 9 triplet in row 4, which eliminates 3, 7, 9 in the rest of the row. This can't be 3, it's 8. This can't be 8, it's 3. 8 eliminates 8 here, so it's 6 and 8. That means this can't be 6 anymore. It's 7. 7 and 8 are consecutive, so this can't be 8 here. It's 9. 9 eliminates 9 here, so it's 4 and 9. 7 eliminates 7 here. 3 eliminates 3 in the rest of this row. 5 eliminates 5 here because of 5 in the box. And it eliminates 5 here, so where is the 5? On this Nabner line, it has to be here. So that eliminates 5 here, so that's 8 and 5. 8 eliminates 8 in the rest of this row. So this can't be 2 because that adds up to 10. 7 and 5 eliminate this 5, 7, and 6 eliminate 5, 7, and 6 there, so this is 8. 7 here, 7 and 9 eliminates 7 and 9 here, so that's 6, which means this can't be 6 because of 6 in the row. This can't be 7 because it's consecutive with 6, so this must be 8. Okay. 6 eliminates 6 here, so that's 2, which means this can't be 2. So this is 6, 7 here. 2 eliminates 2 in the rest of the box, so this can't be 7 there to add up to 2 to add up to 9 there. We have 3, 7, 9 as a triplet here in box 4. That eliminates 3, 7, 9 in the rest of the box, so this can't be 3 here. Or 7 or 9. 3 eliminates 7 there because that adds up to 10, so if this were 7, 3 would have to be there, but it can't. 4 eliminates 4 here, so that's 1 and 4. 1 eliminates 1 here, so it's 3 and 1. 3 eliminates 3 here, so that's 2. That eliminates 1 and 2 of the rest of the box, so this is 4 or 6. Remaining digits in column 7 are 6 and 7. That eliminates 6 and 7 in the rest of the box, so no 6 there. 5 eliminates 5 in the rest of the box here. 2, 4, 6 or 7, 6, 7 or 9. This digit cannot be 4 or 9 or 6, and it cannot be 1, 2, 7 or 8. Again, for the same problems on this Nabner line, if it's 1, this would have to be 2, 7, but then 2 is consecutive with 1. If it's 2, this would have to be 1, 8, but then 1 is consecutive with 2, and same 4, 7, and 8. So I think this has to, doesn't this have to be a 3, 5 pair? No 1, 2, 7, 8, no 4, 6, 9. Yes, that leaves only 3, 5 as a pair. And 3 and 5, 3 is consecutive with 2. So this cannot be 2, therefore this must be 8 and 1. That eliminates 1 in the rest of the column here. Where is 8 in box 4? This is 3, 7, 9 as a triplet. Can't be there. Can't be here because of 8 in the row here. So 8 is guaranteed to be one of these two digits. And 8 is consecutive with 7, so this cannot have a 7 on this Nabner line. 1 eliminates 1 here, so that's 3, which makes this 1 there. That eliminates 1 and 2 in the rest of the row here. This becomes a 4, 8 pair, which eliminates 4 and 8 in the rest of the row. That leaves this digit as a 3. 4, 8 also eliminates 4 and 8 in the rest of the box, so this can't be 4. It's 1 or 2 here. Remaining digits in this box then are 1, 2, and 5. And the remaining digits in row 5 then are 3, 4, and 6. Because we have the 1, 2, 5 triplet in the row. And this can't be 3 because of 3 in the box, so this is a 4, 6 pair. That 4, 6 pair eliminates 4 and 6 in the rest of the row, so this can't be 4, it's 3. 3 is consecutive with 2, so this can't be 2, which makes this 1. So there's no 1 available here, no 1 available here. And these have to be 2, 4, or 7 here. Well, the thing is, if we try to have 4, 7 as a pair here, that you would guarantee you have a duplicate here. So that's not allowed. So this cannot be 4, 7. It must be 2 and 9, which means 2 cannot be on this line because we already have a repeat. This 4, 7 pair eliminates 4 and 7 in the rest of the row, along with a 3 in the row. This can't be 3 or 4. That leaves this as 1, 2, or 6 here. We have 1 here. 4, 7 as a pair here. 3 eliminates 3 here, so that's 5, which makes this 3. 5 and 3 eliminate 5 and 3 in the rest of the row, so this is 2. That eliminates 2 in the rest of the column. 4 eliminates 4 here, so that's 5. We have a 4, 6 pair in column 8, which eliminates 4 and 6 in the rest of the column. So no 4, 6 here, it's 1. That eliminates 1 here. We have now a 2, 6 pair in row 7. That eliminates 2 and 6 in the rest of the row. So no 2 or 6 here, it's 1. And 2 and 1 are consecutive, so this can't be 2. It's 6 and 4 here, which makes that 8. 6 eliminates 6 here, so it's 2. 2 and 5 eliminate 2 and 5 here. This becomes a 4, 7 pair. Remaining digits in column 6 is a 3. Remaining digits in box 8 are 5 and 9. This can't be 9 because of 9 in the row, so that's 5, that's 9. Remaining digits of column 5 then are 6 and 7. So 6, 7 as a pair. 9 eliminates 9 in the rest of column 3. So, where is the 9 on this Nabner line? It has to be along the cage. So this must be 3 and 9, adding up to 12. 3 eliminates 3 here, so it's 7. 7 eliminates 7 here, so it's 5. No more 9 here. And 7 eliminates 7 here, so that's 9. 7 eliminates 7 here, so it's 4 and 7. 7 eliminates 7 here, so that's 4. 4 eliminates 4 here, so it's 6, which makes this 4, which makes that 6. We sort of have to do normal Sudoku now. Remaining digit in column 3 is a 2. We have 8 ones. We know where the last one has to be. It has to be here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2s. We don't know where the 2s had to be. 3, we have 8 threes, so the last 3 we know has to be there. 4 in column 2 cannot be here because 4 is in the boxes, can't be here because of 4 is in the rows. So 4 has to be there, and that gives us 8 4s. We know where the last 4 has to be. It has to be there. 5. We don't have enough information. 6s. In this 6 eliminates 6 here, so that's 7, which makes this 6, which makes that 7, which makes that 6, which makes that 7. And we have 8 6s now, so we know where the last 6 is. It's there. 7s. In column 9, 7 has to be here because of 7s in the boxes here, and these are filled out. That gives us 8 7s, so we know the last 7 is there. 8s. 8 in row 2 has to be there. We have 8 8s now. We know where the last 8 is. It's there. And 9s, we have 8 and 9, so the last 9 is there. That gives us 2 here, which makes this 5, which makes that 2, which leaves this as a 5. Yeah, apologies. I completely forgot about the Killer Cage rule set. I just sort of ingrained it, and I just completely forgot about describing it. So apologies for that. That will be in the description, though. So, yeah. Anyways, I hope you enjoyed this solve, though. And I'll see you next time on Frank Puzzles. Take care.